second time it's happening to me today. I forgot the recording. Okay, so after we finish this question, just take you back to the portion above.
Sir.
Yes.
Sir, can you show the upper part?
Yeah. We'll just finish with this, then I'll go back. Okay.
Okay,
Just
sir.
complete the verification of this one. Okay. Differentiate this final value that I got and show that it should give me 1 by x square.
Sir, done. I got it.
Yes, sir, I also.
Yes.
Yes, sir. Same here.
Yeah, very good. Okay. So I just show it for everyone else also. So differentiation of minus 1 by x is minus times differentiation of x to the power minus 1. Okay, so that is minus 1 into minus 1 x to the power minus 2. So that is 1 by x square. So that verifies this. Okay. Right. So okay, those who have finished writing down this part and all, just do one more question. I'm putting the example on the top right corner here.
Sir, I want to write down.
Yeah, I'll take you back there also. Okay. Now this is the next question that we are going to do. Dx upon square root of x. Okay, so if you finished with this, take it back to okay, the next example, just try it out yourself. Okay, very good. Rishita, that's correct. Swayam, that's correct. Okay, so first we'll bring this to the numerator by, so the value of n becomes minus half, and then it's just a matter of applying the formula. So you have to just get used to applying this formula, just like we had done in differentiation earlier. And you'll notice like the formula is like a reverse of differentiation. When we differentiate x to the power n, we reduce the power by 1 and we multiply by n. When we integrate, we increase the power by 1 and we divide by n plus 1. So it's like, it's logically opposite of that operation. Yeah, I just got disconnected there for a moment. Let me share the board. Yeah. So I think I got disconnected while I was explaining. So the next thing we are looking is the exception to the above formula of x to the power n. That is the case when n is equal to -1. So n equal to -1 case is, or that's the same thing as 1 by x. So this is given by the formula natural log of x plus c. So this is x, because the simple logic of this is that we know from before that the differentiation of natural log of x is 1 by x. So naturally the integration of 1 by x should give us ln x. So the only function whose derivative is 1 by x is ln x. Okay. So therefore the integration of 1 by x should give us natural log of x plus c. So this we should remember is the exception case. For all other powers of x other than -1, we use the above formula, the x to the power n plus 1 upon n plus 1 plus c formula.
So what you have done on the right side with that red, which you double tick?
This formula,
Yes, sir.
this is the formula for this case. When how to solve this integral, no? X to the power -1 or 1 by x, the answer is this, ln x plus c. This is the formula for it.
So only if n is equal to -1, then we will use this formula, right?
Yes. This is a specific formula for integration of 1 by x or integration of x to the power -1. It is given by the simple formula ln x plus c. And the logic of that formula is below, that differentiation of ln is 1 by x. So integration of 1 by x should be ln x. Yes, better.
Sir, if we not use this formula, it will be okay, no?
If we
not use this formula and use that x to the power n plus 1.
But we can't apply this formula when n is -1. No? That is the whole thing. This is the exception case for that formula. No?
Oh,
See, try
yes.
using n equal to -1 in that formula and it will give you an undefined quantity, no? Because the denominator will become 0 on the right hand side.
Okay, sir.
So you have to remember this special case, that no, you will use that formula for all possible values of n except for one, and that is that which one, n equal to -1.
Done, sir.
Okay.
So just a minute.
Yeah. Right. Now the next thing is the properties which are also like similar to how we learned properties in differentiation. So the first one is that if we are integrating a constant, it will give us a linear function. A is a constant. I'm not writing it as C because we're already using the symbol C for the constant of integration. So I'm just using the symbol K instead for any constant. You can use any symbol, it doesn't really matter. So for example, integration of 5 is 5x plus C, because you know that differentiation of a linear term is a constant. So you can see the logic behind this, that if you were to differentiate 5x plus C, where C could be any constant, it doesn't matter what the value of C is, you always get 5 as the answer. So the integration of 5 should be 5x plus C, of course. Okay. Or for that matter, if it's even a negative quantity, it doesn't matter. Minus 3 dx. So this will just be minus 3x plus C. Or if it is even an irrational number like pi dx, this will just be pi x plus C. Or it's 1 by pi dx, it will be x by pi plus C. So that is the first property. Now the second property is something very, very similar to what we learned in differentiation. If we are integrating a constant multiplied by a function, we can just take the constant outside the operation and continue with the integration. So for example, we want to integrate 5x with respect to x. So 5 is a constant, we'll just bring it out. And x is x to the power 1. So we'll use the x to the power n rule. That integration of x to the power n is x to the power n plus 1 upon n plus 1 plus c, except for when n is equal to minus 1. So n should not be equal to minus 1. So invoking this formula now, this will become 5 into, now x's power here is 1. So it's 1 plus 1 divided by 1 plus 1, this whole thing plus c. So as you can see, this becomes 5 by 2x square plus c. And it's quite easy to check that this is the antiderivative of this function. Because if you were to differentiate this, you'd get 5x, whatever the value of c is.
So,
Yes.
so on the right side, 1 upon pi dx, the value should be pi raised to the power minus 1.
So, no, 5 is the constant, no, beta.
Sir, pi.
Pi, okay.
Right side.
Nee, that's okay. But pi is a constant, no, beta. So it doesn't matter whether it's in the denominator or numerator. No, 1 by pi is a constant. No? So just think of 1 by pi as the k. So what is the answer? Kx plus c.
Yes, sir.
Got it? Understood? No?
Yes.
So like that, for example, if we are integrating 1 by 10 with respect to x. Now 1 by 10 is just a constant. So integration of k dx is kx. So that is 1 by 10 into x. So that is x by 10 plus c. Okay, now just try out these couple of examples below I'm writing. This one, then okay, these three examples, just work them out. So this is just systematically applying the properties and of course the fundamental formula that we have for x to the power n. That's
Okay,
okay, so just send me the answers once you work out these three examples after noting down this these two properties, of course.
Sir,
Okay, very good. Sakshi, Ayan, Sanvi, Pihu, Swam, all of your answers seem to be correct. I'll just verify. So first take the 2 outside, then apply the formula. That's the first one. Take the constant outside, then apply the formula. So take the constant outside and again express it as x to the power minus half. Okay, so hope all of you are getting these values.
Yes, sir. Yes, sir.
Okay, very good.
Yes, sir.
Yes, sir.
Yeah, Rishita, your answers are also correct. So, now,
Sir, I got the same thing, but I forgot to simplify it.
okay, no problem. So it's clear now.
Yes, sir.
Sir, in third one,
Yeah.
it won't be x raised to the power 3 upon 6.
No, but it's
Okay.
minus half plus 1 now. N's value is minus half now.
अच्छा, okay.
Okay. 3 by 2 kab hoga when we have this integral. Suppose we have root x. Then this one is x to the power half. So this will become x to the power 3 by 2 divided by 3 by 2. Or it's 2 by 3 x to the power 3 by 2 plus c.
Sir, in fourth one, at last you did differentiation. No? Differentiation, no?
Hey, beta. Integration, beta. I'm increasing the power by 1 na, and dividing by n plus 1. So that's integration. Integration only, no? Differentiation में what happens to the power? It becomes n minus 1, no?
Yes, sir. Yes.
Okay. Okay, now sometimes you can also have a question which is just given like this, like suppose I have 5x squared divided by root x. So you have to simplify this a little bit before you integrate. So just work this out also. Okay, so here 5 will go outside, but then Now you apply the formula. Yes, Rishita, very good. Aryan, correct. Sorry, Ayan, correct. Swayam, little bit of mistake there is in your solution. Just check once. Okay, that's correct now. Anahita and Swayam, both your answers are correct. Good. Veer, correct. Manas, correct. Sanvi, correct. Very good. Okay, so I'll just complete this now. So this becomes 5 into x to the power. This will become 5 by 2 divided by, also it will become 5 by 2. So it's basically nothing but algebra. Just step by step, you have to patiently solve, nothing else. Just like you had learned to do in differentiation also, same kind of thing. So this is the antiderivative of this. Okay, the final property, the third and final property.
Sir, could you just wait 1 minute?
Yeah.
Yes.
Okay. So the third and final property is this one, that sort of distributive property. If we have the sum of two functions, their integration will be the integration of the first function plus the integration of the second function. Or for that matter, if there's a minus sign between the two, then there will be a minus sign between the two integrations. Okay. Only one thing here, when we combine them as a sum like this, we don't need to write two separate constants. Okay. So for example, if we have integration of, let's say, x plus x square. So first step, we'll use the distributive property. Now second step, when we are solving these integrations, this is x square by 2 plus some constant, let's say c1. This is x cubed by 3 plus some other constant c2. Now we can take c1 plus c2 as a combined constant c, because these two are indefinite. So their sum is also indefinite. So in our final answer, we don't need to write two separate constants. We just need to write it as a single constant of integration, a combined constant of integration. So this is now the antiderivative of this function. You can check yourself and see that if you want to differentiate this function, regardless of whatever is the value of that constant c, you would always get the derivative as x plus x squared. Get this as this. So let's also work out some examples.
Sir,
Yeah.
sir, in the example which you wrote for the third property, you
Yeah.
wrote integration x of dx. You wrote x square divided by 2 plus c1, right? Sir, so can you tell me how you wrote x square?
X square by 2, how that came?
Yes.
That is integration of x. ना बेटा x का power कितना है? 1 है.
Okay, sir, understood.
Okay, so n is equal to 1. So x to the power 1 plus 1 upon 1 plus 1.
Okay,
Same way for x square. X to the
square.
power
Okay.
is 1 upon 2 plus 1. So these are just coming from the formula, direct x to the power n formula. So same thing you have to do here also. So yes, again Ayan and Rishita correct for the first one. Same for Anahita. Anahita, just a second. Be careful. Your answer is partially correct. Like the second term, you made a small mistake.
Okay, sir.
Remember, integration of a constant is a linear term, no? Integration of k dx is kx plus c.
So can you please solve first one?
Sorry, what was that question again, beta?
So can you please solve the first one?
The first one, okay.
Sir, can you check the answers?
Yeah, I'll check the answers also. So see, first one, you have to separate out the integrals, okay? So this 2 will also come out when you. So this
Sir,
is 2
in the second case which you took out, that nothing came, no? 3dx only integral.
Yeah, I mean, you can take the 3 outside also, then you will be left with 1 inside. Okay. So it's like you can solve
Okay.
something like this also, no? That you can say that.
So x ka power becomes 1 there. Value means.
Nee, this is actually just 1. No? It's 1 into dx. No? So integration of 1 into dx is what? It is x. Because differentiation of x is 1. So like that, integration of 3 dx is 3x. That kind. Okay. So that's how we get this. This is the first one. Second one, I'm directly writing it out after simplifying it. Okay. So it becomes this. Now again, we won't write 3 separate constant terms. We will just integrate the first one. So that's x cubed by 3. Then the minus sign in between, x integration is x square by 2. then integration of 1 is just x. So this becomes our answer. Okay? And the best thing about integration is you can always verify your answer yourself, because if you differentiate this, you should get this, the quantity inside the integration. So that will just verify that it's correct. Okay? Now for
Sir?
third and fourth, yeah.
So there should
Yeah.
be 3 multiplied with it, right?
Sorry, there's a 3.
Yes.
My mistake. Yes, there's a 3 here, so that 3 will come here also. Correct? Okay.
Yes.
So initially you can keep the 3 inside the integral symbol, but then it will come outside because it's a constant. There's a minus sign in between these two. Okay. So, all right. So this is the second one. This is the first one. Okay. Now third one, I'll just start by giving you a hint. There's a whole square, na? So we need to simplify it first. Okay, so before you put any property of integration and all this, you need to solve the whole square by using the a plus b whole square formula. So first step, you need to open this bracket. So it will be a square plus b square plus 2ab. And then proceed. Okay. So here I'm just using this identity.
So 2ab will come na, so root x into 1 upon root x.
Product of root x into 1 by root x is how much? Is 1, no?
Sir, could you please check the answers?
Yes, I'm checking it. Yes, Rishita, your fourth one is correct. I'll go back and check the ones also.
So in this third one, we have to first solve the a plus b, the whole square equation, right?
Yes, yes. Sanvi, your answer is correct. Very good. Rishita, your third one is also correct. Very good. So third and fourth both are correct. Ayan, your third one, you made a mistake in one integration. Remember the exception rule. Okay, I'm giving you the hint. Just remember the exception rule. So this next step here.
Sir, can you check mine also?
Yeah, check. Now this is the exception case. X to the power minus 1's integral is ln x. Yes, very good. That's correct. And as I said, like you can always quickly verify your answer yourself. Just mentally differentiate this and see whether you get this term or not. You'll get, when you differentiate this, you'll get the answer in this form. But then this is equivalent to this only.
So third one's answer is that one.
Yeah,
X.
this is the answer.
Final.
X square by 2 plus natural log of x plus 2x plus c. Now, of course, it doesn't matter what order.
Yes.
Fourth one is what? X cube minus 1 whole divided by x. Okay. So again, a bit of simplification we'll have to do first. And again, the exception case will come into play, because when we do this, we'll have that 1 by x integration again. Okay. So now just apply the appropriate formula.
So,
Yes.
can you read the third question answer once? Only the answer.
X square by 2, okay, plus natural log of x, that is ln x, plus 2x plus the constant c.
Okay, sir.
The integration of x is x square by 2, integration of 1 by x is ln x. And the third term is constant, no? So it's a linear function. So 2 dx is integration is 2x plus c. Yes, Piyu, you have a question, better?
So it means by looking to the sum when it is a negative value, it means we have to apply that exceptional formula.
Whenever the power of n is equal to -1, you have to apply that ln function formula.
Okay. So,
Yes, better.
so in this, like I simplified it as x cube upon x minus 1 upon x.
X cube minus,
I simplified it as x cube upon x minus 1 upon x, like that.
yeah, that's correct. No? So x cube upon x is x square only, no? See the second step I've written. So it's the same thing. No? X cube by x is basically x square, no?
Okay, so actually I differentiated x cube and then I differentiated upon 1 upon x also, like that I did.
But why you are differentiating? Here we are doing integration, no? Beta?
Yes, sir. So I got confused.
Okay. Now you understood, no? Acha, you are thinking of that UV rule kind of thing, no? That is for differentiation.
Yes,
This is
sir.
integration. No, beta? So here we won't apply that.
Okay, sir.
Done, sir.
Okay, so these questions are clear, I think.
Yes, sir.
Yes, sir.
Now a couple of more formulae of integration we'll see. So the basic trigonometric functions integrations. So at the moment we will require only 2 integration formulae out of the 6. Later we will discuss about the other 4 also. Now with this formula we just have to be a little careful. Integration of sin x is minus cos x. Okay. Whereas you remember that differentiation of cos x was minus sin x. So that is why differentiation of minus cos x will be how much? It will be plus sin x. Okay. So differentiation of minus any constant, any arbitrary constant is sin x. So this is the logic of it. Whereas integration of cos x is sin x plus.
So
These are the
it's opposite with symbol.
yes, because differentiation of sin is cos. Okay. So integration of cos is sin. But differentiation of cos is minus sin. So integration of sin becomes minus cos. And the other one we'll look at right now is the exponential one. Now this is the easiest function as always because differentiation of e raised power x is e raised power x. So integration of e raised power x is also e raised power x but plus c. So this is the entire set of the basic integration formula. Okay. Now there are some more formulae also, but that we will learn with few more things on the way first. We'll learn something called integration by substitution. With the help of that, we will learn how to integrate the other 4 trigonometric functions, that is tan, sec, cosec, and cot.
Sir,
So
Is it compulsory to write a C after every function?
Absolutely, because without it, it becomes wrong. Na? Without it, it means
Sir,
that the
but then C tends to 0 now, ultimately.
that is the whole point. C can take any value. C can be infinite also. So if you are saying that, you're taking the value of C as 0, then you are saying that integration of cos x is always sin x. Now my argument will be, what if I take sin x plus 100? Is the derivative of sin x plus 100 equal to cos x or not? It is, no?
Yes.
So that's why we have to always write the C without fail.
Okay, sir.
Sir, the thing which you wrote in the right is the rechecking, no? Antiderivative.
Yeah, it's just showing you the logic of this formula, where it is coming from.
Done, sir.
Okay.
So 1 minute.
Yeah. So we'll just see a couple of examples again of mixed questions. Okay. So sin x plus 3 cos x integration. Yes, very good, Rishida. That's correct. Very good, Ayan. That's correct. Swayam, that's correct. Sanvi, correct. Sakshi, correct. Rishita, your second answer is also correct. Very good. Sakshi and Sanvi both correct for the second one also.
So can you check for third answer?
Yeah. Okay, so I'll just write down the answers first. Okay, then explain the questions. So this is going to be minus cos x plus 3 sin x plus c. Okay. This is 2 e raised power x plus x cubed by 3 plus c. And this one is going to be so if this is confusing, you just understand it this way. 1 by root 3x can be written as 1 by root 3 into 1 by root x. Okay. So integral of 1 by root 3x can just be written as, so there's,
Sir,
yeah,
sir, 2x raised to power 3 by 2 whole divided by 9 will simplify to your answer for third.
what was it again? 2x to the power?
3 by 2 whole divided by 9.
Okay. Then, no, it's not the same as this, no, beta.
Okay.
Something has gone wrong. Just check your calculation.
Yes, sir, I check.
Okay. So I'm doing the steps here above. Okay, just check. That we can write like this.
Okay, sir.
So,
Hmm.
so can you please explain the first question once?
Sir,
Okay,
in
first
the
one.
third, I'm sorry.
Yeah, I'll just finish the first one. Okay, then we'll come back to third. So in this, the only thing you do is you use the distributive property and then you use the formula. Okay. Now you can see from above the formula of sin x's integration is minus cos x and cos x's integration is sin x, but there's a 3 in front. Understood now?
But so cos x dx is equal to sin x plus c, right? So,
Yeah, so the constant is combined now when we add two terms. So this c
oh,
is a
okay, sir,
combined
I got
constant.
it.
Got it? No? Okay.
Yes, sir.
And the third one, you're just getting rid of the root 3 by taking 1 by root 3 as a constant outside. The logic of that I've written on top over here. Square root of 3x can be written as root 3 into root x. No? Therefore, 1 upon
Yes,
square root of
sir.
3x can be written as 1 by root 3 into 1 by root x. That 1 by root 3 just becomes a constant. You take it outside the integration symbol.
Sir, done.
Okay, done now.
No, sir,
Sir,
please 1
please
minute.
wait.
1 minute.
Okay, okay.
Sorry.
No problem. It's fine.
So can you explain me the second last step in third one?
Explain. Sorry, which one again, better? This,
The second last step.
the third question, no?
Yes, sir.
Okay. So second last step, this one, no? Here to here, right?
No,
So
sir,
this
more
is
down.
more down. Okay.
Two.
So this. So see, this is divided by half, no? So 2 goes in the numerator, no?
Yes, sir.
Understood? So this 2 has just come to the numerator here. Okay. And here what I've taken is I mean, then next step. Sorry. This is root x in the numerator. So I've just combined this root and finally written it. This
Yes,
way.
sir. Okay. Done, sir.
Okay, good. Okay, now see the next level of integration we will see is where we have to use a little bit of substitution concept. Okay, somewhat similar to like we did in chain rule for differentiation. So just for example, that last question that we did, it was root 3x inside the square root. So we were able to resolve it very easily. We were able to do it like this. Okay, and then we could proceed with our formula based method. This was this example. But suppose we had an example where instead of this, inside the square root, we had 3x plus any constant like plus 2. Then we would get stuck now. We can't solve it by this method now. Because it doesn't matter if I take the 3 outside or not, there'll be still some constant left over here.
Yes.
Okay. So this has to be solved by using a method called substitution. Let's discuss what this substitution is. So there are 2 types of substitutions that we will learn. Okay. The first is extremely simple. Because in the first one, what we do is we substitute a linear term as a dummy variable. Okay. So for example, I have integration of, let's say, 3x plus 4. So here I will substitute 3x plus 4, which is a linear term, as z, which is my dummy variable. So I'll explain the solving later. So here also, for example, in this above one also, I'll have to substitute 3x plus 2 as a
Sir. Sir is struck, right?
Yes.
Yes.
Okay, people, let's continue. I got disconnected again, fortunately. Anyhow, so we were talking about substitution of a linear term. So the general situation is that if we have a function of a linear term, okay, then this linear term can be substituted as a dummy variable. So this is our substitution step. And once we do that, you can see that dz by dx is the differentiation of this linear term. So that is nothing but a, because here a and b are constants. So the moment dz by dx is a, that means if I cross multiply, I can say that dx is equal to dz by a. So this quantity as well as this quantity will be substituted in the original integral. So in this integration, on substituting these two, so ax plus b is substituted as z, and dx is substituted as dz divided by a. So a being
Sir,
a constant.
the right side, how you got that? I'm not understood.
Which one, beta? Dx is equal to dz by a, this one?
Yes, sir. And up also you wrote A.
Yeah, so it's coming by differentiation. No? Differentiation of ax is how much? A. For example, what is differentiation of 3x? It's 3, no? What is
Yes,
differentiation of 5? It's 5.
Five.
So like that. Differentiation of b is how much? 0, because b is a constant.
Acha, understood, sir.
Then what you wrote after general?
General case, beta. It is the general case.
Okay, sir.
So once we substitute z as ax plus b, and we also substitute dz as, dx as dz by a, now it reduces to the regular integration. So this becomes 1 by a of integration of fz, which is iz. Okay, and then we resubstitute, because z is a dummy variable we have introduced. So it becomes I of ax plus b. Okay. So the thing is, this will initially seem a little awkward and lengthy. So just make a quick run through of this, and we will discuss this with a couple of examples where we actually implement this, and then you will
Sir,
understand that this
what's
quite.
I?
I is the antiderivative. Okay. So I is the antiderivative or what we get by integrating of only the variable has changed from x to z. Okay, so it's I is what we get by integrating that function fz with respect to z. Okay.
For an example
So, yeah,
one, that
now
is
we'll come back to the example. Don't worry. Okay, just write down up to here first.
what I am asking in the example one, that is e raised to 3x plus 4.
Plus, what is it? 3x plus 4. Yeah. Yeah. Okay, so I have not completed this example. I have not solved the integral yet. I'm just showing you that what type of example we'll apply this situation in, where we substitute the linear term as a dummy variable. So this is the first type of substitution that we're learning. It is substitution of a linear term. So just make a note up to this general case below. Then we'll solve a couple of examples using this, and it will become clear.
So can you zoom out a little bit?
Okay. But just it might become very small. Okay, let's see.
So we can adjust it by our
Yeah.
need.
Yeah, you're able to magnify it. Yeah, so it's fine. Okay. Okay, I'll take you to the steps below also. Just write down up to here first, up to that heading of general case. Okay.
Sir, in this slide, can you explain that last box which you made in red color on the right side? Dx is equals to dz upon a. That one. Sir,
So,
Sir, we are not able to hear you if you are speaking.
Okay, so you've written down this part now?
sir. Sir, can you explain me that red box right side में dx is equals to dz upon a?
That's just cross multiplication, beta. dz by dx is a. So just cross multiply the terms.
Okay.
Sir, what does A represent?
What does?
Sir, A represent, you equated the equation with A.
I didn't understand what you're asking, beta. What did I do?
Sir, above the red box, you equated this equation with A. So, sir, what is A?
A is the constant, beta. I explained that before. The differentiation of ax plus b. See, what is z? Z is ax plus b. So what is dz by dx? It is differentiation of ax plus b. So that will be a, no?
Oh, yes, sir. Yes, sir.
so,
Yeah.
so what is it after 30? It's sorry, 3x plus 4 in the bracket.
3x plus 4 is equal to z, which is a dummy variable. Now we are substituting dx 3x plus 4 as our dummy variable.
Okay, sir. Thank you.
So you can use any symbol, but generally I use the symbol z for dummy variable, right? So it's very similar. That substitution step is similar to what we used to do in chain rule application in differentiation, but only this is not chain rule. This is integration. Okay. Yes,
Sir.
Piyu, you have a question, beta? Yeah.
Yes, sir. Sir, last में you removed 1 upon a and then f z you written as I antiderivative, na? That last में.
Yeah.
Second one.
Yes, this is the antiderivative. Yes. Iz is the antiderivative of fz. Okay. So don't worry about this symbolic language. When we do an actual example, this will become clear. So let's take up that example we had taken above, which was dx upon square root of, what was it, 3x plus something, no? 3x plus 2, I think it was. Doesn't matter, whatever it is. So that's a
Sir,
constant.
3x plus 4.
3x plus 4, okay, fine. So the first step we'll do here is we will substitute. So we'll substitute this whole linear term 3x plus 4 as our dummy variable. Okay. Then after that, this complicated term of square root of 3x plus 4 will become simple of square root z. But the thing is, this dx term will remain. So we need to convert dx in terms of dz. So that is where this step comes in, that dz by dx is going to be how much? It's going to be 3, because it's the differentiation of 3x plus 4. So if dz by dx is 3, that means dx is how much? It is 1/3 of dz. So this will also need to be substituted. Along with substituting 3x plus 4 as z, I will also need to substitute dx in the numerator in terms of dz. So my integration will now become, after the substitution, the integration will become, the numerator will be dz by 3, the denominator will be root z, and that 1/3 is a constant, so I can just take it out. Okay. Now this is a simple enough integration. Okay. So just as we know that integration of x to the power minus half dx is x to the power minus half plus 1 upon minus half plus 1 plus c. So that becomes 2 root x plus c. So just by that logic only, integration of z to the power minus half will become 2 root z plus. Only the name of the variable is different. It's z instead of x. Rest the steps are same. Now we need to resubstitute because z is the dummy variable, so we need to remove it. So on resubstitution, z should be how much? 3x plus 4. So my antiderivative is 2/3 of square root of 3x plus 4 plus c. So this is the integration that this is the antiderivative of.
Sir, what confusion?
Yes, Peter, tell me what confusion?
No, sir, means I understood but a little bit.
Yeah, we have to practice few questions, then it will become clear. Okay.
So done.
Okay. So
No, sir, 2 minutes, 2 minutes.
right. Anyway, so we'll conclude this session here today, right? So with this, the basic type of integration by substitution is done. So next lecture, we will discuss more about integration by substitution, and we'll discuss about the next type of integration called definite integration. And with that, we will complete calculus.
Chapter completed then, sir.
Yes, we will finally complete calculus in the next lecture. And following that, we will start with kinematics at your competitive exam level. You have already had one lecture of kinematics with me for the board level, but we will now do a more detailed study of kinematics for your entrance exams.
Sir, you will start kinematics with the beginning, no?
Yes, yes. In this track for your competitive exams, we'll do kinematics absolutely from the basics, okay, regardless of the board lecture. But you should also go through the content of the board lecture once. It will help you with when you have your internal school exams or college exams or whatever.
Okay, sir.
Okay, so that's it for today's session, people. Wish you all the best. Thanks for attending. Have a nice evening.
Thank you, sir.
Thank you,
Bye,
sir.
sir.
Have a good
Thank you,
evening.
sir.
Thank you, sir. Bye, sir.
Okay.
Bye, sir.